In this little video, I'm going to show you what happens in positive transcriptional regulation. So in positive transcriptional regulation, for some reason or other, the actual reason varies, the sigma factor, which I'm not going to show you, cannot easily recognize and bind to the promoter, or even though the sigma factor is bound, the RNA polymerase can't bind to the sigma factor and to the start of the gene. There are, again, several different reasons for this, and we're not going to go into those. We're just going to sort of generally say that in genes that require positive transcriptional regulation, the RNA polymerase cannot locate or bind to the promoter for some reason or other. So it's like, where is the promoter? I can't find it, right? Okay. So in order to get transcription of these genes, we require the activator. Ta-da! Here it is. So the activator, we're going to make it this long rectangle shape, binds to the activator binding site. The activator binding site is a regulatory site in the DNA that is upstream of the promoter and, somewhat obviously, also upstream of the coding element. So when the activator is present at the activator binding site, it helps the sigma factor and RNA polymerase to recognize and bind to the promoter. Aha! There's the promoter. Clip, transcribe. Okay. When the activator is off, again, we get minimal transcription. All right. So we're going to start, again, by talking specifically about the inducible gene. So you'll remember that inducible genes are involved in catabolic processes. So we're going to initiate expression of these genes on demand when we encounter the nutrient that the gene is used to produce the protein that catabolizes the nutrient, whatever. Okay, so we make these on demand when we find the nutrient of interest. Okay, so here is the misshapen activator protein in the cytoplasm. Okay, when the nutrient is encountered, either the nutrient itself or a metabolite of the nutrient is going to come into the cytoplasm and act as the inducer. The inducer is going to bind to the activator, change the shape of the activator, change the shape of the activator so that the activator can now bind to the DNA. It's the appropriate shape to bind to the DNA. The activator binds to the activator binding site, permitting the sigma factor and RNA polymerase to recognize and bind to the promoter. And transcription will happen. Okay? So the inducible gene, when it's under positive transcriptional regulation, is expressed when the activator is bound at the activator binding site. All right. The other type of gene is, the repressible gene. So the repressible gene, you'll remember, is typically involved in anabolic processes. So we're normally going to be expressing this gene until we have enough of the required protein and we no longer need it. So in this case, the activator is going to start out bound to the DNA because we are wanting to have transcription of the gene in order to make the protein that's going to be involved in this anabolic process. When we've made enough of the protein, we want to inhibit or downregulate transcription. And so in that case, another small effector molecule called the inhibitor is going to come and bind to the activator, change the shape of the activator to a shape that will not easily bind the DNA. The activator falls off of the DNA and goes into the cytoplasm. Then the RNA polymerase is having a tough time, well, the sigma factor / RNA polymerase is having a tough time locating and binding to the promoter, and so transcription is dramatically decreased.